Nicholas Copernicus, the father of modern astronomy. Copernicus was born in Turin, Poland on February 19, 1473, and died on May 24, 1543.
In 1512, Copernicus became a cathedral canon in the North German city of Frauenburg, now Frombork in Poland. This appointment assured him a financial security for life. It was no sinecure though, he had administrative duties to perform. Even so, he found time for astronomy. He set up an observatory in a small turret on one corner of the cathedral. By 1514, his astronomical reputation had become so considerable that he was called upon by the Fifth Lateran Council to help with the planned reform of the calendar. During this period, he wrote his first astronomical work, entitled Commentariolus, or Little Commentary. It already contains a sketch of his new system, which placed the sun in the center of the universe. Had the idea for his heliocentric or sun-centered worldview from his reading of classical texts, which first introduced him to what was in his eyes a revolutionary concept. All astronomers knew that at certain points in their orbits, the planets appear to move backwards. The ancient Greek scholar Aristarchus of Samos had investigated this retrogression, as it's known, and come up with an explanation. If the Earth is also in motion and is moving around the Sun faster than the planets in more distant orbits, then at certain points it would overtake them. Viewed from the Earth, it would look as if the other planet was going backwards. Aristarchus's idea was not followed up. It simply demanded too great a leap of the imagination. How could birds find their nest, people asked, if the Earth had meanwhile moved beneath them? Copernicus, however, was fascinated by this idea and drew up three theses of his own. Number one, the Earth rotates on its own axis once every 24 hours, so that the daily motion of the stars is only apparent. Number two, the Sun is at the center of the universe and the Earth revolves around it. And number three, the Earth is just one planet among others and does not occupy a special position in the universe. Copernicus showed by calculation that the movements of the planets could also be explained by the heliocentric hypothesis, in other words, that they too revolve around the Sun. But the new Copernican system was still pretty complicated. As he could not prove his theories, he could only achieve success in an intellectual climate that was open to new ideas, one that was prepared to question the opinions that had been handed down from antiquity. Copernicus decided to play a waiting game. After all, the geocentric system was defended by the Church, on the basis of the scriptural text in which Joshua was said to have commanded the sun to stand still. But in order to do that, it would have had to have been moving. In other words, this text was not compatible with the heliocentric view propounded by Copernicus. He was well aware of the explosive nature of his theory. That was why he hesitated to publish his views. But he did not stop his researches. But even in Olstein, he found time for astronomy. He took measurements of the sun's altitude in order to determine the date of the equinoxes. But Copernicus was now hooked on his heliocentric worldview. In 1542, he finally allowed his theses to be published in Nuremberg. He was on his deathbed before he saw the publication of his major work under the title De Revolutionibus Orbium Coelestium, on the revolutions of the celestial spheres. He was no longer sure he could take it all in when a copy was pressed into his hands. Although the work was dedicated personally to the Pope, it was placed by the Catholic Church on the Index of Banned Books in 1616. But that did not lessen its pioneering and fundamental importance in modern astronomy. The Middle Ages were dominated by a self-centered view of the world. Copernicus took a broader view and thereby opened the way to our modern image of the world.